Hello everyone, my name is Shyam Manavat and I welcome all of you to the series of lectures on progressions. We are in lecture number 5 in which we are going to discuss arithmetic-geometric progression. This is a concept builder video guys, so let's get started. Arithmetic-geometric progression looks like this, where, let me write it properly, so it's 1, then you got 2 by 7, you got 4 by 7 square, you got 6 by 7 cube, you got 8 by 7 to the power 4, and so that's so on. Yeah, we need to find out sum of infinite series here. Let's consider the sum of infinite for all the sum up till infinite term as x. Now, do you see that the numerator here is 2, 4, 6, 8. The next is supposed to be what? 10. It's in AP, arithmetic progression, and the denominator here 7, 7 square, 7 cube and 7 raised to 4 with a common ratio of 7. The denominator is in geometric progression. Yes, but obviously you can't add numerator separately and denominator separately, right? You need to add the term with the next term. Okay. So this kind of progression, are you able to identify this kind of progression? That's called AGP. Yeah, where you have a part of term progressing as arithmetic progression and the remaining part of term is progressing as geometric progression. Yeah, so are you able to identify this? Yes. Now, for such kind of question, such kind of progression, again, you have a specific method to progress. You have a specific method to solve this kind of question. So what do you do in that case? And this will repeat. This will repeat for such question. So please understand the method well. First of all, we assume the sum up till infinite term for this kind of progression as a variable or a number. I mean, you can assume as an alphabet. I assume this as x, variable x. Okay, then next step what you do is you multiply this entire progression, left hand side and right hand side. You multiply this entire progression with common ratio of geometric progression. Yeah, so what do? You multiply. So you identify the common ratio and then you multiply the series with common ratio of geometric progression part of the series. Okay, that means you identify the geometric progression part in the series and also find out the common ratio. So here, do you see the common ratio here is 7? Yeah, the common ratio is 7. Or some people may also say the common ratio is 1 upon 7. It will get you the same answer. You look at this as denominator or look at this as 1 upon 7 and 1 upon 7 square. So in terms of fraction, 1 upon 7 and 1 upon 7 square. Or you look at this as 7 and 7 square. Okay. Accordingly, your opinion for the common ratio may change. But trust me, in both cases you will get the same answer. Yeah. So I keep it simple and I will be using r equal to 7, the common ratio equal to 7, which is the geometric progression part of the series. Yeah. And then what you do is you multiply the entire series with this common ratio. So left hand side become what? 7x. And the right hand side become what? 7 multiplied by the entire series. Okay. So it will look like 7x here and then 7 multiplied, so it becomes 7 plus the next term is what? 7 into 2 by 5, 2 by 7. Next is 7 into 4 by 7 square. Yeah. This is the first question of this type which we are solving. So I am writing all these steps where you can skip this step. Okay, this step is extra, that is just for understanding, just for me explaining to all my Dear students, 7 multiplied by 8 by 7 to the power 4, and it goes on. Now look at this. Can I cancel this 7 with 7? Yes. Can I say this 7 by 7 square will be only 4 by 7 now? 7 into 6 by 7 cube. So if I cancel this with 7 cube here in the denominator, I will be left with what? Only 7 square. Similarly, here 7, if I cancel with this 7 raised to 4, the denominator will be left with only 7 cube. Do you agree with this? Yeah. 7 raised to 4 means what? 7 is multiplying itself 4 times. So out of that, if you cancel 1, you will be left with only 7 multiply itself only 3 times. So you will be left with 7 cube. Clear? Okay. Now this 7x will be like 7 plus 2 plus 4 by 7 plus 6 by 7 square plus 8 by 7 cube plus so on up till infinite terms. Are you comfortable? Are you comfortable with this? Yes. Now look at this x term which we got here. Yes. Tell me. If you subtract this 7x, if you subtract this 7x with x, yeah, or if you want me to name it, this is, let's say, equation number 2 and this is equation number 1. First of all, did you understand the simplification of equation number 2 after we multiplied 7 to both sides of the series? Yeah, we multiply 7 into the entire series. Did you understand this? If yes, what you do? You mark this as equation number 2, mark this as equation number 1, and then what we do? We do second minus first, the equation number 2 minus equation number 1. Okay, so 7x minus x will get you what? 8x, no, 6x, my bad, 6x equal to, now see the subtraction here. Now look at the subtraction and pay attention to this. These two terms, 7 plus 2, 9, has no denominator. So I will subtract this with a term here having no denominator. 1 by 1. So denominator 1 is nothing, right? Yeah. It is simply 1. So 7 plus 2 is 9. 9 minus 1. Yeah, that is going to get you what? 8. Plus, now see this. 4 by 7 minus 2 by 7. That means we are comparing this 7 denominator 7 term with denominator 7 term. Yeah, we can also subtract this 4 by 7 with 1. Numerically, mathematically it is possible, but we don't want to do that. We want to take this term 4 by 7 and this term as 2 by 7 and then subtract these two. So 4 by 7 minus 2 by 7 will get you what? 2 by 7. Yeah, have patience, have patience. Just wait for a few more minutes. You will understand why am I doing this. Now 6 by 7 square, I'll subtract with 4 by 7 square. What will we get? We get again 2 by 7 square. Yes. Plus then 8 by 7 cube, subtract 6 by 7 cube. You have what? 2 by 7 cube. Plus, now next term definitely would have been what? 10 by 7 raised to 4. And if you subtract this with this term, although these terms are enough, but just to explain you again got what? 2 by 7 raised to 4. And it will go on up till infinite term. Now observe this part. Observe this part. Look at this part. Guys, spend more time in understanding the concept. It will be easy for you to understand the shortcuts later. Spend more time in understanding the concept. Observe this term. What did we get after subtraction? So we subtracted the next term with the previous term of AP. If you get to see, we subtracted the next term with the previous term of AP. So 4 minus 2 you got 2, 6 minus 4 you got 2, 8 minus 6 you got again 2, 10 minus 8 you again got 2. So the arithmetic progression part of each term got subtracted with the next term. So after subtraction, what are you left with? Only common difference of the AP part of the term. Am I making it complicated? Think again. You are left with only 2, and 2 is nothing but what? 6 minus 4, 8 minus 6, 10 minus 8. Yeah, so basically the common difference of the AP of given terms, arithmetic progression of given terms. Do you agree with that? Yeah. And the geometric progression terms, that remains as it is. 7, 7 square, 7 cube, 7 raised to 4. That remains as it is. Okay. Fine. If you are done with this observation, then what you do is, what this is, it was important to understand this observation. What you do next is, you got 6x equal to 8 you already have. Now from rest of the terms, I take 2 common, yeah, because 2 is there in each term. So I take 2 common. Then what are we left with? We are left with 1 upon 7, 1 upon 7 square, 1 upon 7 cube, 1 upon 7 raised to 4, and so on. Do you not find this as geometric progression? Are you not finding this as geometric progression? Pure geometric progression, nothing else. Yes, that's why we have done all this panchayat. We multiplied by the common ratio of the geometric part of the series, so that I can shift the series a step ahead and then subtract with the previous series which we had. So you have what? The next term subtracted with the previous term. So you are left with 2, which is the common difference of the arithmetic progression part of the series. And then that you can see, it's a common difference, so it will get you same values there of AP part of the term. You take that common and then you are left with only GP. Okay, if you did not understand, don't worry, I have one more question, few more questions to explain this, but are you comfortable so far? If not, then please repeat this part of the video. Okay, and as I said, for this specific type of question, AGP, Arithmetico-Geometric Progression, these steps they are the standard steps. You can go through them, standard steps. Okay, so here if you simplify this GP, up till infinite term, right? Question said find up till infinite term. What is sum of infinite for GP? A, the first term, here it is 1 upon 7, 1 minus common ratio. Common ratio is also 1 upon 7 in this case. Simplify this further, what you get? 8 plus 2 into 1 upon 7 by 6 upon 7. Yeah, by 7 by 7 cancel. So you got only 1 upon 6 there. Now what do you do next? What do you do next? You say that 6x is equal to 8 plus 2 into 1 upon 6, which is 1 upon 3. I am writing all this step because it is a concept builder videos, guys. It's a concept builder video. Yeah, it's a concept builder lecture. Simplify this. Here you get 25 by 3. This is 6x. So here x will be equal to what? 25 by 3 into 6. The answer is what? 25 by 18. Yes, that's the answer. This is the x which we have taken as sum of the original series which we wanted to find out. This is what we wanted to find out. X, sum of infinite this given series, right? And we got x is equal to how much? 25 by 18. So this is the answer. Leave the calculation apart, but did you understand the concept? Yeah. Let's repeat in short. What did we do? We considered the series as x multiplied by the common ratio of the GP part of the terms, and then we subtracted what we got as result. We subtracted with the original series. We got this step here, this step here, and then rest is all calculation. Yeah. Try this again for this particular question. So you can pause this video and look at the question, try attempting it by yourself. Let's see how do we solve. So what do? We consider the series as x. So we got x is equal to 3 upon 4 plus 5 upon 16 plus 7 upon 64 plus 9 upon 256. Now by looking at the series, can you tell me the next step, the next term of the series? 3, 5, 7, 9. So next should be what? 11 as the numerator. 11 as the numerator and denominator 4, 16. So denominator is progressing with multiplication of 4. You see, 4 4s are 16, 16 4s are 64, 64 4s are 256, and then now you have 256 4s are. So what do you get here? 1 0 2 4. Yes, it will keep on going like this. Yeah, okay, correct. Okay. Now what do? What is our next step? We multiply this entire series by the common ratio of GP term. So common ratio of GP term, I take it 4. As I said, some may take it 1 upon 4 also. Some may take it this common ratio is 1 upon 4 also. Answer will remain same. At the end you will get the same answer. Personally, I don't like to use fractions. It will again increase the complexity of the question. Keep it simple. That's my opinion. You can use 1 upon 4 also. Now if I multiply this entire series by 4, what do you get here? 4x equal to 3 plus. Can I write like this directly without getting into too much detailing of this calculation? Yeah. So 4 multiplied by 3 by 4, you have only 3. 4 multiplied by 5 by 16. So 5 by 16 into 4. 16 and 4 will get cancelled and you are left with only 4. Similarly here, 4 multiplied by 7. Yeah, 4 multiplied by 7 upon 64. So you have what? 7 upon 16 left. Then 4 multiplied by here, 4 multiplied by 9 upon 256. Yeah, so here you will left with what? 64. So you have got 9 by 64 here. Now by looking at this progression, can you tell me the next term? It should be what? 11 upon 256. Correct? Now we mark the first one as equation number 1, the second one as equation number 2. Now what do? We do simply second minus 1. Yeah, we are following the same steps as the previous question. So 4x minus x will get you x, and here 3, and there is no integer term in the previous series. So I will write this 3 as it is because I want to subtract this 5 by 4 with 3 by 4 to get what? 2 by 4. Then I want to subtract 7 by 16 with 5 by 16. So I get 2 by 16. Right? Similarly, next we'll get 2 by 64. Next we'll get 2 by 256. And it goes on. Yeah. Now what do you have here? X is equal to 3 is fine. You can take 2 common. Yeah. Then you have 1 upon 4. Yeah. See, the common difference of the AP term you can take common now. Yeah, because you get only that, and then rest once you are done. So in a way you have eliminated the AP part of the series and you got only GP part of the series now. What are you left with? 3 plus 2 into simplify 1 upon 4, sum of infinite for this GP, right? This is now you got this as GP now, right? where the first term is 1 upon 4 and the common ratio is also 1 upon 4. Simplify 1 upon 4 by 3 upon 4. 4 simplified. You got, okay, by the way, after subtraction you get 4x minus x, right? So my bad, this is supposed to be 3x. After subtraction you get what? 3x as the left hand side. Yes, thank you guys. And I have seen that many students, there were a couple of, one or two, some here, there, instead of 2 I have written 3 or something sometimes. So I appreciate the student who identify the correction, and I will try to remove that, correct those corrections and get you the right and flawless, yes, flawless is the right word, flawless explanation of any question. So here you get what? 3 plus 2 by 3, that will get you 9 plus 1, 9 plus 2, 11 by 3. This is what? 3 by x. So x will be what? 11 by 9. Okay, this is what we wanted to find out. So this is the answer. Are you following all the steps here? Is this looking better than and simpler than the previous one? Because previous one I've gone too much in detail in the first question. Yes, so I hope you're understanding how to solve AGP, Arithmetic-Geometric Progression. What are the steps do we need to follow? So this is it in today's lecture. My name is Shyam Manavat signing off. I will see you in the next lecture. Till then, stay happy, stay healthy and keep learning. Bye bye.